Okay, so now Radovan and I are going to talk about using shared resources responsibly. So we figured we would try to treat this like as a podcast where we'll try to keep our discussion going. So we have talked about this this restaurant with this queue manager, and I think we can build on that, because there are huge advantages with being on a cluster, but those advantages can also be abused. So I can't remember if Espen mentioned it earlier today, but so when you go to a restaurant, you can't use half the tables for 5 minutes if you have a lot of people running in and out. But you can do that on the HPC system. So
Magnar, maybe I can ask you. So I'm also really looking forward to restaurant analogies, because I always like them. Restaurant analogies and kitchen analogies. Maybe just to make clear, so we will, this next session, we will do it as a discussion. So there won't be, maybe we will demonstrate something, but there won't be any exercises anymore. So everybody please lean back. But the best way to participate for everybody is that please ask lots of questions on this hedgehog. So I'll be watching these questions. I will also ask Magnar questions, and we will try to keep this as a discussion.
So I wanted to share an example. So we have this thing called be kind to the login nodes and other users. So it can be a bit frustrating when you're waiting for your job to run. So it can be very, very tempting to use the login nodes. I don't know if you had an experience with that, Radovan. So this is an email you'll get if you abuse the login nodes. So I'm guilty of that, apparently.
So can I ask you, what are typical things that, so here something happened, something you didn't want, but so what is it that likely happened?
So I was setting up some Conda environments on Friday, probably preparing for this week, and I'm guessing something I installed there took a lot of time. And when I exited the node, when I went home from work on Friday, the process didn't quit, and it was probably running on the node the entire weekend. So that's my guess. So do you know if we can use Conda, or do we have access to Anaconda, what's it called, Conda Forge on the compute nodes?
Oh yeah, that's a really good question. So I'm actually not sure. In principle yes, but it might require 2 additional commands in the run script. But maybe we can take a step back. So what are the things that we should do on a login node, and what are the things that we should not do on a login node and rather put in a job script? Or how do you work? Also, when you decide I need to do something, edit some file, what do you put into a script, and what do you do interactively on the terminal on a login node?
So I usually try everything on the login node. If I want to compile something, I try to compile it on the login node. But if it takes a few minutes, at some point there is some breaking point. Where that breaking point is, I'm not sure. But if it takes hours to compile something, you should probably write a job script to compile it.
And I can maybe offer also my view on this. I always put these things into a job script, whether it takes 5 minutes or 5 hours. And the advantage for me is then I document what I actually do because I have to document it in the job script. If I do it manually on the login node, then half a year later, there is no way I remember this. And this will also prevent me from accidentally running anything on the login node. If you try this and you experience that you cannot reach the network on the compute node, please reach out to us on the help desk, and we will show you how you can fix that. So I know it's fixable. I just didn't want here to create too many confusing answers. So it is possible to use the network also on compute nodes. I personally like to script everything because then it makes it more reproducible. The other thing that I often see on the login node is that somebody wanted to actually run on a compute node, but it accidentally went into the login node. And maybe the person forgot an S badge. Sometimes we see a job that uses 20 cores on the login node, but this was maybe not intentional. And it's not a compilation, it's an actual run. And then we might reach out. And this is not to police people, it's really to make the system usable for everybody. Because if I make the login node unusable, then other people will complain. And this is also the reason why we have several login nodes, not only one. And you land on different login nodes in round-robin fashion. So we hand them out. So it's like, if we are back to the restaurant, it's like having actually multiple restaurants with the same name. And this is also to balance a little bit the many users on the same system.
You really feel it if more than one person is running a lot on your login nodes, then things get really slow.
And how about editing files? That's fine. So editing files is totally okay on a login node, writing your job scripts. How about copying files? What is a good way to, maybe we will come back to it later. If I need to transfer files from my computer to the cluster, or from cluster 1 to cluster 2.
That's interesting, because what I usually do, I don't have that very big files, but I usually do it on the login nodes. But that's probably not a good idea if you have huge files and you're running in parallel. So I can't remember if that was covered in the rsync or not.
Yeah, so it might have been mentioned in rsync. So if we talk about how to transfer files, always use rsync if you can. It is, to my knowledge, one of the most efficient ways, especially if you have many tiny files. If you have very many small files and you use SCP, you might notice that this takes excessively longer than one big file. But for rsync, it doesn't seem to matter. And then you mentioned parallel. It is possible to transfer files in parallel. So if you have terabytes and terabytes, and you realize that transferring this from my computer to the cluster would take, I don't know, 2 weeks, then also please reach out to us. So there are other ways to do it quicker, but if it's an excessive amount of data, it's better if you coordinate with us, because then we can guide you towards, and we know about it. Because also there it's possible to actually saturate the bandwidth, so the data cable with, and then other people will notice again.
Yeah.
There is a good question on the HedgeDoc about the scratch variable. I'm not sure we talked about it earlier, but this is something that exists on some clusters, maybe all of our clusters, I'm unsure. Personally, I prefer to use explicit paths, because then I'm not dependent on somebody defining that variable or forgetting to define the variable. I prefer to explicitly tell my scripts, copy from this cluster work to cluster home to cluster projects, and I personally don't rely on these variables, but they are defined.
That's very good.
So should we say more about login nodes and compute nodes? Maybe interactive. How about interactive jobs? Did we talk about them or not?
We haven't. So yes. I also want us to discuss adjusting memory, number of cores, and these things. But yeah, let's do the interactive nodes, because that's a very good point. So I probably wouldn't. The first time I compile something, I would probably try it on the login. If it takes more than a few seconds, then I would move to the interactive job before I use a job script. Because the job script, I have to get everything right. But when I'm on an interactive job, I can make mistakes and figure out how it works on demand.
So an interactive job is really it's running on a compute node, but it's not a job script. So it looks like interactively I type commands and I run my computation, but it's then really running on a compute node. And this can be, and we link to, so on the page that we see, there is a link to how to do that. And that can be really useful if it's the first time I'm trying to run the job. It will probably crash. It will probably crash straight away after 1 second because I'd made a typo somewhere. And then it's really boring if I write the job script and I submit it and it's in the queue for half a day and then it crashes 1 second later. And then I forgot this typo, then I fix this thing. It will again crash on something else. And then interactive jobs can be a nice way to either for debugging or for calibrating a new calculation. And then once I know that this is working, then I write the job script. And then I can submit 200 similar job scripts.
Yeah, that's a very good point. So let's look here. So something I think is a really, really good job, a good idea, is to run a test job. So when we have this, we talked about it a bit yesterday, that, okay, just allocate enough time, enough memory, and you're sure that that the job will finish. So a problem with like reserving 1 week of time to run a job that takes 1 hour, maybe 2, is that you have to wait a long time in line to get the job running. But if you have a test job, you get an idea of how long running the job takes. You don't reserve the cluster for more than necessary, and you don't have to wait in queue for longer than necessary.
And this is so great advice, because a question we get often, and I think we got the same question yesterday and today, is that, well, how long should I ask for, and how much memory and how many cores? And it's difficult to answer before you know the job. So we need to get to learn our job. We need to learn how much time does it need, how much memory does it need, how many cores does it need. And it's really a good idea to calibrate it before submitting 200 similar jobs. Because once I know, then I can vary the parameter, and I know that it takes approximately 2.5 days. But before I submit all of these jobs, and maybe then which don't use the resources optimally, we create this test job and we calibrate. This is a very good practice. It's also good practice if you move from one cluster to another, because just because I know that it took 2.5 days on cluster A doesn't mean it will do the same thing on cluster B.
Yeah, that's.
So how do you do it in practice, Magnar? Like the test job. So what do you really do then?
Yeah, so I compile my program. So I come from chemistry, and there and the problems there are like iterative solutions. So I know that my calculation might converge at usually around 20 iterations or something. So what I can do is I can do the first calculation with where I say, okay, I only want to do one iteration or two, and based on that, since the program I'm working with mostly, I know that each iteration takes about the same amount of time, and I can extrapolate from that how much time I need to run the calculation. So I believe these things are very program specific. If you're so there's always some guesswork here, and that's why this advice is written in our documentation. It's okay, add 20%. So 20%, it's not so much longer that you won't get into the cluster in a reasonable amount of time, but it's long enough so it should ensure that you're able to finish your calculation.
It can sometimes be useful. One trick I sometimes use is that I try to make the system smaller. And everybody here who listens knows what this means in your domain. So either smaller molecules, smaller matrix, or smaller dimensions, which can give me often information about how much will the real calculation need. And often people hesitate doing this because they say, well, but then the chemistry is wrong, or the biology is wrong, or you know, the geology is wrong. But it can still tell me a lot about the job. And then I can go back into the real system, into the real chemistry, real biology. But then I know that, now I need to multiply everything times factor X. So this can be useful.
Yeah, that's so usually, at least if you used your program a while, you kind of know how it scales. So most programs don't scale linearly with system size. But
scaling, now you mean scaling like by making it bigger, right?
Yeah, making it bigger. Mm-hmm. So sometimes if you double the system, it takes double the amount of time, but sometimes it takes 10 times the amount of time. But if these things also come with experience, so you learn, you get to know your program.
Yeah, some of you run calculations that have time steps, and then instead of running 2000 time steps, I would start by running 10 of them, and then I see, this takes 5 minutes. Now I can extrapolate to 2000 time steps. How do you find out how many? So we are now looking at memory, right?
Yeah. So I think this was actually not memory, but memory is let's see if we have a memory example. So I also, so with the test example, in the slurm output, it usually prints the maximum amount of memory used. That can be useful. I don't have an example handy for that, but yeah, it's a very good idea to see how much memory your program used. And if you remember, it can also be good to check when you run the job that you're actually using all of the resources you're paying for. That's something I've seen more than once, is that we have users that reserve 3 compute nodes, but they run their program with 1 thread on one of the nodes, and the rest of the nodes and threads are idle. And the user has no ID, which is a shame, because if they were able, if they set the computation up correctly, things would go a lot faster, and they could do a lot more work in a shorter amount of time. So I will see if I can find an example of a Slurm script. Or
We
Slurm
have all these pages that are linked from the material, how to choose the number of cores, how to choose the right amount of memory. We have examples of different ways to figure it out, so people can also try it on their own and try it with your own scripts. One very simple way that is really effective, and now we are back to the test system, is that when I now calibrate my calculation, I'm new on the cluster, or I'm trying something new program, is that I run it on, first, I'm just guessing, so I'm gunning, I don't know, I will guess I will run it on 20 cores. And then I compare it with how does it run on 10 cores, and how does it run on 40 cores. So I do a bit of a calibration, and it will give me an indication of what is maybe a good setting. Because you will notice that by adding more and more cores, at some point the time spent doesn't go down. At some point you will notice that the time even goes up. And it is not a good idea to guess and keep some setting. Maybe I got some setting from a colleague. So I first calibrate, and once I know, then with this setting, I can run a series of calculations. So this calibration, both in terms of time, number of cores, and memory, will be very useful. You will save resources. So you will have more project cost account left for your other calculations. And also other users will be happy on the system because they will queue less. And what we really want is we want to maximize the number of publications per CPU hour. That's what we really want.
I see that we are running out of time, so I want to end with showing everyone that we have a documentation page, and we have these boxes here that are like this getting started. It's a great place to learn these things by yourself, and I hope it's useful for you to read it. So
there's one more question 31. So in what order are we doing this calibration? Do we start increasing cores or memory or nodes? How do you do it?
I always start with the memory. The memory issue is if you have too little memory, the job dies. So it also depends a bit on which system you're on. So on Saga, you share the node. So there you have to specify how much memory you need. And if you specify too little, your job dies. If you take too much, you block the node for other users. So I start always, when it comes to the number of computer nodes, I start with one and I see if I can, then I see how long it takes, and then I try to add more computers to it until, so at some point it doesn't help adding more computers, the calculation won't finish faster. So it's a dynamic process. You try to add some cores, try to add some memory, but at least from my experience is that it's more about limiting memory than increasing it. And if the process dies due to memory, it's easy to, or usually it's easy to just increase the memory you ask for. Do you have anything you want to add there, Radovan?
Well, I can add that it's good advice. Sometimes it's complicated because sometimes these settings are not independent of each other. So sometimes I cannot modify the number of cores without modifying the memory. But if I can, I often start by setting the memory approximately to what the core has. And then if I really need more, then I increase, but then I will also notice. And then in terms of cores, then I start with 1 core, 2 cores, 4 cores, 8 cores, 16 cores to get a bit of a feeling. And I often go from small calculations towards a larger calculation, so I grow it. You could go also the opposite way, start with something gigantic and then cut it down, but that will be, you will spend a lot of time because it will sit in the queue. Because Slurm doesn't know that it takes only 5 minutes. If I ask for 1 week, it will think that it will take 1 week.
So thanks for the discussion, Radovan, and thanks for good questions in the document.